Time for some more kitchen table astronomy with Hampshire College astronomer Dr. Salman Hamid, Mr. Universe. Apologies for having to bump you from our regular Monday slot on the show, but you got bumped by an astronaut, so I figured an astronomer would be okay with that.
It's an honor to be bumped by an astronaut.
And you're going to go see the movie at Amherst Cinema on Thursday that talks about how hard it is to say goodbye to somebody, like when they go to the International Space Station.
So The Longest Goodbye is the movie. So yeah, I'm really looking forward to it. And when we think in terms of space travel, this is just sort of like, in orbit here, but these are some of the things that we will have to really think about when even looking for sort of like, colony settlements on the moon, but certainly for Mars.
Yeah.
So it's a hard problem.
Well, the moon and Mars are relatively close by, but what we're talking about today is the farthest star.
Yes. So, Monty, last year, Hubble Space Telescope,
which is still kicking it, still doing good things despite having a fancier brand or new space telescope out there with James Webb.
Yeah, Hubble is still there, and a lot of respect for that, by the way, But anyway, last year it detected the farthest star from the Earth. And we are not talking about a galaxy. So oftentimes we talk about, hey, we have found like this smudge, which is the farthest galaxy in the universe, so on and so forth. No, we are talking about a star. It detected a single star 12.9 billion light years away. Or in other words, its light started when the universe was only 900 million years old, and its light just got to us, and we are talking about a single star.
That's pretty cool. How did we observe this? How did both Hubble and now James Webb observe this? Because it got a boost from one of our favorite forces.
Right, so this is actually one of those crazy things which, you have to salute to human creativity and the universe. Don't forget the universe.
Sometimes the universe gives you a gift.
That's
Not
right.
necessarily in an astrology kind of way, in an actual astronomy kind of way.
That's right. So gravity can bend light. So this is again going back to general theory of relativity from Einstein and things like that. But the key context is that we have figured out that if you have a large mass, say for example of galaxies, which are called galaxy clusters, they can actually bend light from objects that are farther away from it, right? And if you bend light, basically you create a lens, and you have similar kind of effects, meaning to say you can have multiple images, you can have magnification, and you can have distorted images. So just like how your glass lens does, all it's doing, what a glass lens does, is changes the direction of the light, and it creates all of these things. In the same way, mass can do the same. And so in this particular case, there is a pretty large cluster of galaxies named WHL 0137-08.
That's a memorable galaxy cluster name.
Hey, it is pretty cool, which is located about 5.5 billion light years away. Okay, but as you can imagine, there is a lot of universe behind it. So it distorts light. It's a pretty massive cluster. It's about sort of like 1,000 Milky Ways, like the galaxies.
Like a good haul on Halloween.
So 1,000 Milky Way galaxies can fit in terms of mass. And so it bends light from whatever is coming from behind it. And as it happens, one of the sort of like galaxy lights, it's sort of like bend, and it's a bit of a sort of like it's an arc, which is called sunrise arc. You should actually go online and look for sunrise arc. You will actually find this beautiful image from Hubble Space Telescope and also from now James Webb Space Telescope. But as it happens, in this bend of arc, in this arc, you see two clusters of stars, and in between there is a single star. And astronomers, when they use the Hubble Space Telescope, they actually looked at its distance, and it turns out to be that this star, which they named it Earendel, from
Lord of the Rings?
Lord of the Rings and prequel, Silmarillion. And
It's spelled differently, though, right? It looks like ear
Yes.
and Dell.
That's
as opposed
right.
to Arundel.
well,
but
as
maybe,
it
I don't know.
as it turns out, it was also in Old English. It turns out that it means sunrise or the morning star, and so I think that's how they sort of like morning star. So they changed it a little bit differently. By the way, nice job, Monty. Like, hey, it's spelled differently. Fact check here. But so this particular star, it just happens to be lined up in a way that its light is being magnified, and we on Earth can see it. So it's a pure coincidence, but its light is magnified 4,000 times, and we can see it. So that's what was done by Hubble Space Telescope, and we knew that it would be one of the early targets from James Webb Space Telescope, and now there is a beautiful image from James Webb. Again, please go and see, sort of like, you can search for Earendel star, James Webb Space Telescope, and you will see a beautiful image in that arc, and we now know a bit more about that star.
It's crazy because we have these space telescopes that can see better into outer space because they're in space and they don't have Earth and its atmosphere in the way. And then sometimes space itself decides it wants to act as a telescope to assist our space telescope. So it's a perfectly lucky coincidence.
Space squared. You're absolutely right. I mean, you won't be able to see that type of resolution or that type of details from a telescope on the ground. But space telescope can do it, and then the universe provides you with sort of like these amazing line of sight magnification sometimes. So remember, you need a big cluster of galaxies to bend light enough, and then you need something in the back from the light coming in, and it has to align where we are here on Earth. And so it's really, I mean, if you just think about it, yes, I know, and we're gonna talk a little bit more about what they found, but I just find this concept, like, that we can figure out as humans that, what, gravity can bend light, and if it bends light, we can actually figure out magnification, that something would be magnified, and then we can study those. I just think that is mind-boggling, because to me, clusters of galaxies themselves are incredible, but they are like, hey, no, we're just using it as a magnifier, looking at it, what's behind it. So I just think that's really cool.
So what do we know about the early universe? What did you say, 900 million years after the Big Bang, from this particular star, Earendel, that we can see because of a boost of gravity with our space telescopes?
Right, so the question was, well, what are we going to find? And one of the thoughts were that maybe it's not a single star. We cannot resolve it. I mean, now you're pushing it too much. If you say, hey, can we just see a dot?
Can't you take your fingers and open them up like this and blow it up like you can on your phone?
But what James Webb Space Telescope found was that it looks like that the star is what astronomers call a B-type star, and which means that it's about bigger than our sun, about twice as hot as our sun, but 1,000,000 times more luminous. And so it's bigger than our sun, which is accurate, but there are stars that are bigger than this star as well, Earendel as well. But it's a big star, and we know that perhaps there is a companion to it, which is slightly redder in color. And the way they can figure out is because James Webb Space Telescope works in the infrared, near sort of like in the infrared part of the spectrum, which Hubble Space Telescope could not. And they can analyze the light, and there is some contribution, it looks like, from another star. We don't know the details, but it looks like it's a binary star, which is not surprising because half of the stars in the universe are binary stars, meaning one star orbiting another.
Not just on Tatooine. It's real.
That's exactly right. And especially like big stars, they also have a binary companion. So that is not surprising at all. But it's really cool that we can actually tell, like, hey, here is a star whose light started 12.9 billion years ago, and it's a binary star. That's actually pretty cool. And I should also add that, remember I mentioned sort of like there were also two clusters that they found? Well, James Webb Space Telescope has also analyzed the light from these two clusters. As it turns out, these are where new stars are forming. One of the clusters is less than 5 million years old, meaning to say it's very young. But the other cluster is actually probably it's more than 10 million years old, but it looks like that it's a cluster that is stable. And so one of the questions that come in, well, so what has that got to do with us? Well, this is a way we think that globular clusters, these are clusters of stars, sometimes about 1 million stars or so, and many of them are in our own galaxy also, in the Milky Way. And we think that is how they formed billions of years ago in our Milky Way as well. And here, by looking so far away, we are seeing a globular cluster in some sense in the process of formation. So by looking at this gravitational arc, we are seeing information potentially about how our own galaxy was formed.
Every single star is like a time machine coming from all sorts of different points in time to us right now. So depending on how scientists have viewed the what is it?
Spectroscopy.
Spectroscopy, they can tell how far away something is. So you could theoretically come up with a timeline of how things, how galaxies, how Milky Way are born, potentially looking back in time by using our telescopes.
Yeah, except I should mention that sometimes people get confused about the fact that can we see our own Milky Way back in time? We cannot, because we are in here. So I mean, we can
Can't see the forest for the trees.
Well, no, but it's also one of those cases that we already have the light from the Milky Way, from stars from the Milky Way. So even if you look at the center of the Milky Way, it's about 30,000 light years away. So we can only see 30,000 years back in some sense.
Which is a long time in human years.
But not in terms of if you're looking for stars, because they live billions of years, right? So, but we can find other galaxies that are far away, and we can imagine that if they are like the Milky Way, and we can imagine, okay, well, that is how Milky Way would have been like, then we can learn from them about ourselves. But we cannot go back in time to see our own past. We can infer our past by looking at some other galaxies.